Hello, 7th grade mathematicians. This is Ms. Holliman coming to you with a lesson on one-step equations. I thought it was important that we focused on one-step equations because it is somewhat of a building block to bigger things in mathematics as it relates to algebra. For instance, pretty soon we'll be discussing two-step equations and inequality. So it's very important that we kind of get a grip on these one-step equations. And so I thought it was important that we kind of review a little bit on one-step equations from last year and some things that you may have picked up on this school year. All right, so it's very important that we know that the goal in one-step equations is to isolate the variable. Okay, and what does Ms. Holliman mean by isolate the variable? We want to think about how we can take any type of one-step equation and get the variable alone or by itself on one side of the equation. So let's say we have the equation x plus 5 equal 9. It's important that we know that an equation is separated into parts by its equal sign. Okay, so the equal sign determines one side from another side. So this is one side and this is another side. So what we want to do is get the variable on one side all by itself. So that's what isolate the variable means. Okay? Now, this is one equation. I'll put another equation up here. Let's put 3n equal 12. Okay? So these are two different types of one-step equations. They're both one step, but they're two different types. Now, the first type, the x plus 5 equals 9, is a one-step equation that has a plus 5 on the same side of the variable x. Now, that plus 5 represents a constant term because it's not stuck to the variable like glue. Alright, in order to get rid of plus 5, which is our goal, so we can get the variable over here by himself, we want to subtract 5 on both sides. Because with algebra, whatever you do to one side, you do to the other. And the goal is to get rid of plus 5, so you have to do the inverse operation of plus 5, which is minus 5. Okay, so when we minus 5 on both sides, we'll see that x will indeed equal 4. Alright, on the second equation, 3n equals 12, it's important to notice that our variable is kind of stuck to the number like glue. Whenever you see that the variable is stuck to a number like glue, like for instance 3n or n over 3 or 1/2 x, that number that's connected to that variable is called a coefficient. I like to call it the COE. Alright, so to get rid of the COE, or the coefficient, you have to do the inverse operation of what they give you. So in this case, I would divide by 3 on both sides. So 3 divided by 3 is 1n, and that equals to 12 divided by 3, which is 4. And 1n we know is just n equals 4. Okay? Now, some of you all might be curious about these right here. Okay, if I had these in the equation, of course, this is the same one. You would divide by 3 here. This one you would multiply by 3 because they give you n divided by 3, and you want to do the inverse of divide by 3. You want to multiply by 3 to solve. On this one, I like to use that reciprocal. So I always say multiply by the reciprocal whenever you have a fraction. So I will multiply by 2 over 1. Okay, so here we have a word problem. When we see word problems, it's very important that we do not get scared. Okay, they're just words, and we can figure it out because we are mathematicians. So a pair of shoes costs $25. This is $14 less than the cost of a pair of jeans. Find the cost of the jeans. Let J represent the cost of jeans. Okay, so I like to draw pictures or make charts or visually picture what this problem is talking about or referring to. So this pair of shoes, I'm going to say, it tells me in the problem is $25. I have to determine in my mind before I try to figure out the cost of the jeans. Are the jeans more expensive or less expensive than the pair of shoes? Okay, so it tells me in the problem this is $14 less than the cost of a pair of jeans. Okay, so are the shoes more expensive or the jeans? Well, right here it says less than the cost of a pair of jeans. This is $14 less than the cost of a pair of jeans. What is this? This is the $25. Okay? So $25 is $14 less than the cost of a pair of jeans. That tells me that the cost of the shoes is less than the cost of the jeans. So the jeans are more expensive. Okay? So one thing I like to do is I like to kind of visualize what this means. Okay? So the shoes plus $14 represents the cost of the jeans. Okay? The shoes plus $14 represent the cost of the jeans. Okay? Another way I could put that is the $14 added to the cost of the shoes tells me how much the jeans cost. Okay? Alright, so let J represent the cost of the jeans. I've already made two different types of equations. And another thing I could do is I could say if I have the cost of the jeans minus $14, I get the cost of the shoes. Okay, so in this problem, it looks like they might be looking for J minus $14 equals the cost of the shoes. Alright, so that's one way to write the equation. To solve this equation, we will simply add 14 on both sides because we're working with a constant. Okay, so the cost of the jeans will be $39. Okay, so word problems, we like to answer with words. So the jeans cost $39. The jeans cost $39. Alright. Alright, so now just a few practice problems. Alright? Some of you all might already know how to do this. But I just wanted to kind of breeze through it real quick so you can get a few examples of what this should look like. Okay? I like to go ahead and kind of put dots on my equal sign. That helps me to determine side 1 from side 2. I look at the side that has the variable, which is this side. And my goal is to isolate that variable. So I want to look, and I have plus 2 in my problem. That's what they give me. I want to do the inverse of plus 2. The inverse of plus 2 is minus 2. So I want to subtract 2 on both sides of my equation. When I subtract 2 here, I get y plus 0, which is just y, equals 7 minus 2, which is 5. My next one, I'll go ahead and put my equal sign as my divider. This is one side versus another side. The side with the variable is this side. I look at that side and I say, what do I need to do to get the variable isolated? Well, I want to do the inverse of plus 5. The inverse of plus 5 is subtract 5. So I want to subtract 5 on both sides. So y is equal to 11 minus 5, 6. Lastly, you'll see a problem that looks like this with fractions. Again, please don't get scared. It's just a fraction and you can defeat any fraction. Okay? I like to rewrite it so that my fractions are kind of standing up because I like to reciprocate and I like to figure out where my denominators are whenever I'm using fractions in an equation. Alright, so I look at it and I say, what do I need to get rid of? And that is the 1/10. The 1/10 I need to get rid of, so I'm going to subtract 1/10 on both sides. So P is going to be equal to, oh, I got to get a common denominator, which will be 20. So I multiply this fraction by 5 over 5, and I get 15 at the top here. You ought to see that. And I multiply this one by 2 over 2, so that be 2 20ths. So now I say, what is 15 minus 2? And that's going to be 13 20ths. Okay, right. All right, so that's how we'll do that. Please don't be afraid of word problems or fractions. A drive-through a safari zoo charges $12.50 per person for admission. In 1 hour, the park raised $675 in admission fees. Write and solve an equation to solve or find how many people visited that hour. Okay, correct my grammar there. Alright, so I like to visualize this. Okay, so a drive-through, a safari zoo charges $12.50 per person for admission. Okay. In 1 hour, the park raised $675. Write and solve an equation to solve how many people visited that hour. Okay, so within 1 hour, there was $675 raised in admission prices. I know that per person is $12.50. Okay, so basically they're asking how many people visited within that hour. Well, I can figure that out by saying $12.50 times the number of people. I'll put the number of people as X equals the $675. Okay? Some of you all might think, oh, Ms. Holliman, I don't need to write an equation for that. I could just figure it out by saying $675 divided by how much each person paid. And that's true. But the equation asks you to write and solve an equation to figure it out. So it's important that you follow the directions. Alright, so think about this. $12.50 per person times however many people came through equals the amount raised. To figure out the answer to this, remember to isolate the variable. Our variable is X, so it's stuck to this number, $12.50, like glue. So remember, that's multiplied, so you have to do the inverse operation to figure it out on both sides. So X is equal to 675 divided by 1250. Alright, so your calculator will come in real handy right here because it's not important that you know how to divide for this type of problem. It's important that you know what to do. Okay, so I will go to my handy dandy calculator and figure that out. $675 divided by $12.50. And that means 54 people came through. And I like to answer with a sentence. So there were 54 visitors to the zoo. Alright, lastly, looking at these one-step equations, and all of these have the form of a coefficient. Okay, so the first one we did was the form of a constant where you add or subtract. The second one that we're looking at are those with coefficients, so you have to multiply or divide. Okay, so it's very important that you kind of get used to seeing equations and figuring out, okay, is this a constant or a coefficient, so you can know whether you need to add, multiply, divide, or add or subtract. Okay, so this one stuck to the variable like glue, so this is 6 times C. I'm going to divide to solve. So C is equal to 3. This one is the same as A divided by 12 equals negative 3. To solve that, I am going to undo division. So instead of saying A divided by 3, divided by 12, I'm going to multiply by 12 on both sides. So A is going to be equal to negative 36. Doing these, it seems a little bit quicker. Alright, my last one is 1/3 n equals 2/9. And I love doing reciprocals, okay, when you flip over the fraction. So simply, I will need to figure out the reciprocal, which is 3/1, that's on the side with the variable, and multiply on both sides by that reciprocal. So when I do that, they cancel out that coefficient, and I'm left with, I like to cross cancel, 2/3. If I didn't cross cancel, I would have gotten 6/9 and then just simplify to 2/3. Okay, so hopefully this helps you a bit as you do some work with one-step equations after this and for your homework. You all have a great day.